Hey guys, Mr. Mackey here. Now yesterday we were making estimates based on complicated problems like this one, and my challenge to you was to make an estimate from this. So what we got to do is we got to round these numbers to the nearest whole number. So we do 3.549 rounded becomes 4, and 2.036 becomes rounded to 2. 5.698 becomes rounded to 6. And 1.867 becomes rounded to 2. Now this side, 0.962 gets rounded to 1, and 3.893 becomes rounded to 4. And underneath, 3.369 becomes 3, and 1.672 becomes 2. So now let's tidy this up. 4 take away 2 is, let me split this up, 2. 6 multiplied by 2 becomes 12. 1 plus 4 becomes 5. 3 times 2 becomes 6. Now 2 over 12 is the same as 1 over 6 when you simplify it. So this is 1 over 6 plus 5 over 6, and that gets us a rough estimate of 1. Now we're moving on from estimates today. We're going to be focusing on the final part of this week for numbers, something completely new. Let's get into it. So you've probably seen this symbol before. This is known as a square root. So what we do is when we find this, we're looking for what two numbers when multiplied together gets you 4. In this case, what numbers when multiplied by itself gets us 4, aka squaring. So the square root of 4 is 2, because 2 times 2 gets us 4. Square root of 9 is 3, because 3 times 3 gets us 9. Now the square root of 2. Now this will not get us a whole number. The reason why? Because 2 isn't a square number, so we cannot do this. This is a special type of number. This is known as a surd. A surd is a number that's being square rooted that will not give us a whole number. So root 2 is actually a surd. Let's look into surds a bit more detail. So, root 121 can be made into a whole number, so it's not a surd, because 121 is a square number. So when you root it, you will get us 11. Now, root 11 is not a square number, so we cannot change that into a whole number. So, root 11 is a surd. Now, root 44 is also a surd, but we can simplify it. How? Well, we have to find two factors that make 44, and one of those factors can be a square number. Let's see what I mean. So we can do 1 and 44, but then we just end up with root 44 again. It doesn't really get us anywhere. We could also do 2 and 22. However, neither of those numbers are square numbers, so we can't simplify it. What about 4 and 11? So what we do is we write root 4 multiplied by root 11. The reason why is because if you were to actually do this problem, you would then end up with root 44. If we have two surds being multiplied together, you actually end up multiplying them as one surd. So root 4 can then be simplified because root 4 gets us 2 because 4 is a square number. So it's actually 2 multiplied by root 11. And what does that get us? 2 root 11. Still a surd, but it's a simplified version of that. So whenever you have a number, try and see if you can figure out a pair of factors that work for it. One is square, one isn't. Then root that square to turn it into a whole number, then multiply it with the other factor, which is still a surd. And that's how you simplify. That might be a bit confusing, but let's do another one now, just so we're sure. So just to help you understand, root A multiplied by root B is the same as root AB. So that's another way of doing it. So I have root 50. Now root 50 will give us a surd, but we can simplify it. So let's find two factors, and one of those factors has to be a square number. We can't do 1 and 50, because even though 1's a square number, we'll then just end up with root 50 again. It doesn't really get us anywhere. What about 10 and 5? Well, neither of them are square numbers, so we can't use it. What about 2 and 25? 25 is a square number, so let's write it down. So it's the same as root 2 multiplied by root 25. Now root 25 we can work out because it's a whole number. So that's the same as root 2 multiplied by 5. So what is root 2 multiplied by 5? Well, clue in the title really, it's 5 root 2. And that is a simplified version of root 50. Awesome! Another rule you can do is if you have two surds, you can add them together just so long as those surds are the same. Let me show you what I mean. Root 50 plus root 2 we can't do because the surd in this one's 50 and the surd in this one is 2. They're not the same number. It won't work. So we need to simplify our root 50, which we've already done thanks to the previous question. So that becomes 5 root 2 plus root 2. This we now can add together because they both have a root 2. So what's 5 root 2's plus 1 root 2's? That becomes 6 root 2's. So all you need to do is you need to remember how to simplify your surds, how to add them together, and how to work through it from there. It's pretty straightforward, isn't it? So let's move on to your challenge for today. So here's your challenge. Using the information I've shown you today, I want you to find this problem and answer it in its simplest form. What do we have to do to these two? What happens if we expanded this bracket? How does it work? Good luck. I'll see you tomorrow. Let's bring on more surds.